In this problem, we're going to factor a binomial completely. Anytime you're looking at a problem and it says to factor completely, the first thing you always check for is a greatest common factor, a GCF. What do these two have in common that we could possibly factor out of both? Well, I noticed that they both contain a 4x. Therefore, we can pull that out. When I pull out 4x, I'm just going to cross off those 4x's to see what's left. We have y to the fourth minus z to the fourth. At this point, I'm left with a binomial here. The only option of factoring when you have a binomial is the difference of squares. So how do we check if it's a difference of squares? Is it a difference first? Yes, we are subtracting. Are the first and second terms perfect squares? Well, they both have even exponents, therefore it is a perfect square. So we can factor this using the difference of squares. So I'm going to drop down my 4x. The difference of squares basically says that one of them is going to be positive, one will be negative. And then in each part here, you're going to take the square root of the numbers that you're given. The square root of y to the fourth is y squared. You just half the exponent. The square root of z to the fourth is z squared. And same here. Now most of the time we would stop here, but we need to check to see if we can factor further. This one here I cannot factor further, but notice here, is that a difference of squares? Yes, it is, because y squared is a perfect square, z squared is a perfect square, and we have a difference. So we can factor this again. I'm dropping down the things I cannot factor further, and this y squared minus z squared can be factored further. Again, one of them is going to be positive, one will be negative. And you take the square root of each of them. Square root of y squared is y. Square root of z squared is z. And these will be the same. At this point, I cannot factor any further.